Good morning, students. Module 3 contains chemical fuels, solar cells, and fuel cells. Okay, first we'll see chemical fuels. What is chemical fuel? A chemical substance which produces a significant amount of heat and light energy when it is burnt in air or oxygen is called chemical fuel. Usually, when it burns in air or oxygen, it produces simple example here, it produces carbon dioxide and heat. For example, if you take methane, it's nothing but combustion reaction or reaction with the oxygen that gives carbon dioxide and water plus heat. Now, how do we classify chemical fuels? Based on their physical state, it can be classified into three uh, groups. One is solid, liquid, and gaseous chemical fuels. But we can further classify these chemical fuels into primary fuels and secondary fuels. Primary fuel is nothing but directly we can get it from the nature. Secondary fuels are derived from the primary fuels. So here we have given some of the examples. What are the primary fuels, or what are the primary fuels we can get it from the nature directly, and what are the secondary fuels derived from the primary fuels in all three states. Now, what is calorific value? It's nothing but it is defined as the amount of heat liberated when unit quantity of a fuel is completely burnt in air or oxygen. It's very important, this definition. The SI unit of calorific value is kilojoule per kg. In calorific value, there are two types. One is gross calorific value and another one is net calorific value. Gross calorific value is also called as higher calorific value or HCV or GCV, and net calorific value is also called as lower calorific value or NCV or LCV in short. Now, what is this gross calorific value? Same definition, whatever we have given calorific value, the difference is in the last line. It is defined as the amount of heat released when unit quantity of fuel is burned completely in air or oxygen and the combustion of products are cooled to the room temperature. Combustion of the products are cooled to the room temperature. So since we are cooling these combustion products, here latent heat of steam also included. So that's why it is called as higher calorific value. And net calorific value, it is also defined as the amount of heat released when a unit quantity of fuel is burned completely in air or oxygen and the products of combustion are let off into the atmosphere. Okay, here we are not cooling the combustion products. So that's why net calorific value is lower than gross calorific value. This gross calorific value of solid or liquid chemical fuel can be determined by Bohm's calorimeter. The principle behind this is a known weight of the fuel is burned completely in excess of oxygen. The liberated heat, when we burn this chemical fuel, heat will be liberated. The liberated heat is absorbed by surrounding water and calorimeter. Thus, the heat liberated during the combustion of fuel is equal to the heat absorbed by water and copper calorimeter. The higher calorific value of the fuel is calculated from the data, or gross calorific value GCV can be calculated from the data. Now, what's a construction? It consists stainless steel cylindrical bomb like this. This is bomb, stainless steel bomb, and there is one platinum crucible. In this platinum crucible, we have to keep weight mass of chemical fuel. And to this weight mass of chemical fuel, we have to connect magnesium fuse wires, okay, to initiate combustion process. And these magnesium fuse wires are connected to two electrodes, and these two electrodes are connected to 6-volt battery. Okay. and there is one oxygen wall for the combustion process. Through this oxygen wall will supply oxygen always at 25 atmospheric pressure. Now this bomb will be surrounded by copper calorimeter containing weighed mass of water. Weighed mass of water, and this copper calorimeter will keep one magnetic electrically operated stirrer and also one sophisticated thermometer, Beckman's thermometer. Okay. Now this copper calorimeter will be surrounded by air jacket and followed by water jacket to minimize the heat loss. So this is the construction of bomb calorimeter. Now uh, before starting this combustion process, we have to note down the temperature, initial temperature. Okay, then we have to keep this weighed mass of chemical fuel and start the combustion process, and we have to note down the highest temperature recorded in the thermometer. So, what are the calculation steps? Here, you have to write down mass of fuel mkg, then initial temperature before starting the combustion process T1 degree Celsius, and maximum temperature after combustion process, or the highest temperature recorded in the thermometer, that is T2 degree Celsius. Now, what's the rise in temperature of water? The difference that gives rise in temperature, that is delta T degree Celsius. Mass of water in the calorimeter, that is W1 kg. Water we have taken in the calorimeter. Now water equivalent of calorimeter, that is W2 kg. What is water equivalent? The amount of water which could absorb same amount of heat per degree rise in temperature as that of copper calorimeter. Copper calorimeter. Copper calorimeter. So that is water equivalent of calorimeter. Now what is next? The specific heat of water, that is S kilojoule per kg per degree Celsius. The heat released by the combustion of m kg of fuel, heat released by the combustion of m kg of fuel is equal to the heat absorbed by the water, and heat absorbed by the copper calorimeter. So that's equal to W1 into S into delta T plus W2 into S into delta T. Simplify this, then heat released by the combustion of 1 kg of fuel is equal to this much. Why do we take 1 kg of fuel? Because in the definition we have stated the amount of heat liberated when the unit quantity of chemical fuel burned completely in air or oxygen. So unit quantity, that is nothing but GCV. So GCV is equal to W1 plus W2 into S into delta T divided by M. So from this experiment you will get GCV. By knowing GCV we can calculate NCV. So for this we have to use this particular formula. NCV is equal to GCV minus latent heat of steam. So that's equal to 9 into 10 percentage of hydrogen divided by 100 into latent heat of steam. Why do we take here 9? Because 1 gram hydrogen gives 9 grams of water. See, in the water molecule, the molecular weight of water is 18. So there are 2 hydrogen atoms. 2 hydrogen atoms will produce, it gives 18 grams of water. So 1 gram of hydrogen, it gives 9 grams of water. So that's why we have taken 9 here, or we can simplify this 0.09 into percentage of hydrogen into 587. If you multiply it by 4.2, then it is in terms of kilojoule per kg. Otherwise it is in calorie per gram. So please remember this formula to solve some numericals.